All right, well, before we move on to 12.3, realized I made a little mistake on the calculation. So our R value ended up being higher than it was supposed to be. And so where I made my mistake was here. So somehow I lost that 0 in front of the 6. So if you hopefully you got that answer instead of what I had before. So everybody was probably screaming out, "What'd you do wrong?" So in this case, if you add up all these, we would now get 6.306 divided by 7, which gives us this R value of 0.9009. So this will be off by a little bit because I rounded a bunch. So in reality, we should try not to round that much at all. But in this case, I rounded just to make life a little bit easier. So you'll see on the next slide here, next classwork packet, that I said that the R value should have been 0.99006, and so that's true if we didn't round any. So because we rounded, it's off by a little bit, but again, it's kind of far off, so it's not that terribly big of a deal. So it'd be different if we were off in the 10th position, but we're off in like the 10,000th position, which isn't quite as bad. All right, so now what we want to do is we actually want to figure out what the regression equation is. So what is the equation that actually models this data? So again, kind of using the exact same value, or same example. So we found in the last section that our R value was 0.9006. From this, we learned the correlation coefficient gives us a strong positive relationship because it's bigger than 0.9. And so what we're trying to do is we're trying to come up with our equation that looks like that y equals mx plus b form. Now, statistics, we don't use the m for slope because the m could mean like median or midpoint or something like that. So that's why we use the a in this case to represent our slope. And so we're using y hat in this case because it's an approximation. So it's not the actual y values. So these are the actual y values. So this is going to be approximating the y values based on the line that we find in this case. So this just gives you a brief idea of what we're trying to do when we're trying to find the linear regression line. So we're basically trying to calculate these differences, how far away they are from some given line. And so our goal is, what we want to do is we want to minimize these red lines and try to make them as small as possible. So notice the one on the left, these red lines are pretty far off. They're pretty long and stuff like that. So even though that linear equation does kind of go through all the points and stuff like that, that doesn't look like it's going to be the best linear equation for this model. Where if we look at the one on the right, notice we shrunk all these red values. So pretty much every one of them is smaller other than this one here, but the other ones are significantly smaller, so we must have done a better job. So this looks like to be a more appropriate linear regression for what we're actually looking for. And so another name for a linear regression is what's called the least squares line, because that's what we're trying to do. We're trying to minimize the squares of those red lines to make them as small as possible. And so if we were lucky and r equaled 1, then every one of these blue dots would actually live on the line. And so again, the smaller our r value is, the closer all these dots are going to be to that line. All right, so let's look at our equation for our regression line in this case. So again, we need to know the sample means and the sample standard deviations and all that stuff. And so what we've got is the slope, our A, is going to be the R value divided by the two standard deviations in this case, so SY divided by SX, and then the y-intercept is going to be the y bar minus A times the x bar, the sample mean in this case. All right, so again, we've already calculated this stuff from the other side, so let's go through and find all the different pieces. So hopefully these match what I had before, so they look familiar, so that looks good. So to find our slope, what we're going to do is take our R value, which I expanded a few digits, again, just to kind of make it a little bit more accurate, times our SY, which is the 29.68, divided by our SX, which is the 269.49. And let me throw this in the calculator real quick. 0.90059 times 29.68 divided by 269.49 gives us an A value of 0.09919 in this case. So again, we should probably, well, let's go the whole way out. I mean, might as well, if I'm going to go that far out, I might as well go the whole way. So 99185540. So the further out you go, the more accurate it's going to be, of course. And so our B value is going to be to take the sample mean from the y, so 447 minus this long A value we just found, 0.991855540, multiplied by the sample mean for x, so 2891.25. So let's do the multiplication first. 2891.25 gives us 447 minus 286.7701927. So subtract 447. So we get that B is 160.229807. So putting these all together, we see that our regression line is going to be y hat equals 0.099185540x plus our b, which is 160.229807. And so again, I just drew it in here so you could see it. So that's what this line actually represents. The blue line in our picture represents that regression line and how close it does to actually modeling this data. So at this point, go ahead, you guys work on practice 1 and practice 2, which is the same data you've been working on. And then we'll just call it quits for the day, and then we'll finish up the last sections on Thursday. So good job.